Hello everyone, today we are going to look at minimum spanning trees. So in the first example you'll see a map of towns in a county and existing major roads between them. We are going to devise a plan that repairs the least number of roads but keeps a route between each pair of towns. Can you find two routes? Well, so we see all the towns. We're going to try to highlight only necessary roads to keep them connected. Alright, this is one of the examples. This is Route 1. There are others. Alright, here's another one. And each of these routes, if you count all the towns, we are going to have 1, 2, 3, 4, 5, 6, 7, 8, 9 vertices and 8 edges. As you can see, this is an acyclic graph, which means this is a tree graph. And you should remember that if we have 9 vertices, we're going to have 8 edges, and the same happens here, right? So a spanning tree is an acyclic connected subgraph that contains all the vertices of the original graph. It's possible to have many spanning trees in the graph. So in example 1A, how can we connect with the least amount of edges? Here you go. We just connected all the vertices with least amount of edges. And as you can count, 1, 2, 3, 4, 5, 6, 7, you have 7 vertices, and you should have only 6 edges. That's a tree. There's your 6 edges. The same in example B. How can we connect these? Here you go. We connected all the vertices with least amount of edges. In the next example, in example C, you should notice that this is not connected graph, so no spanning tree. These two pieces, 1 and 2, are not connected, so there will be no spanning tree. Alright, when we talk about minimum spanning tree, is a spanning tree with minimal weight, so now the edges will have a weight, and there is an awesome algorithm by Mr. Kruskal, which we will explore right now. In example number 2, A, use Kruskal's algorithm to find the minimum spanning tree, and I listed all the edges. Since we are talking about minimum, there's also possibility of maximum, so keep that in mind. Minimum spanning tree, we are going to list all the edges and start with the smallest edge. So we're going to highlight the smallest edge, AB, right over here, which is a 4, and I'm going to add. By the way, the first thing that you should start with is count how many vertices. 1, 2, 3, 4, 5. We have 5 vertices, therefore we're going to need only 4 edges. And we already have one, AB. Then the next one I'm going to pick is AE, which is right here. Alright, and the next one in line would be BE. Now as you can see, BE would give me a cycle. So this edge is out. Sorry. Alright, the next one is CE. So CE is right here, which is a 7. We have one more, and let's see if CD will work. And yes, it does. Here you go. Okay, so here is 4, 5, then we added 7, and we added 8. As you can see, all of these vertices are connected it's a minimum spanning tree, and then all you need to do is add, I believe that's 24, 9, 16, 24. So MST minimum spanning tree for this one is 24.